Welcome to the class, students. How are you all? I hope you are doing well. Today we are going to discuss chapter 12, magnetism. Let's warm up. What do you see in this picture? Which objects are being attracted? Which is the object that is attracting? What property of the object helps it to attract the other objects? So students, look at this picture. What you have to find which object is attracting and which are not. Okay students, you can do it. It's very easy and interesting, and discuss it with your friends. Let's know about discovery of magnet. What is a magnet? Properties of a magnet. Precautions while handling magnet. Uses of magnet. So students, these are the topics we will discuss in our chapter. Here is discovery of magnet. There is an interesting legend related to discovery of magnets. It says that about 4,000 years ago, there was a shepherd named Magnes in an ancient Greece. One day, he was herding his sheep in a region called Magnesia. Magnes was standing on a large black rock, and suddenly the metal tip of his stick and both the nails and the shoes got firmly stuck to the black rock. It was found that when this rock was suspended freely in the air, it pointed to the geographical north-south direction. This rock later came to be known as lodestone. Lodestone contains magnetite, a natural material that attracts metal. So students, how we found a magnet? एक आपके जो है एक पर्सन था ग्रीस में, वो सीफर्ड था और उसने देखा कि जो उसकी स्टिक है उसकी जो मेटल टिप है वो स्टक हो गई रॉक में, और वो रॉक क्या थी? लोडस्टोन थी, और वहीं से आपकी मैग्नेट जो है हमें मैग्नेट मिली। और फिर मैग्नेट में बहुत सारे जो है इन्वेंशंस हुए, कुछ चीजें फाइंड की गई, डिस्कवरी हुई, एंड फर्स्टली मैग्नेट को हमने क्या बोला था? लोडस्टोन. लुक एट दिस पिक्चर स्टूडेंट्स. हियर इज सम पिक्चर्स. दिस इज अ black rock, that is magnet, that is lodestone, and here is Magnes pulling his stick out of the rock. Now we have, what is magnet? A magnet is a substance that has the property of attracting objects made of metals like iron, nickel, cobalt, and their alloys. Metals like aluminium, copper, zinc, gold, silver, etc. are not attracted by magnet. In nature, the magnet is found in rocks in the form of magnetite or lodestone. This is called natural magnet. The magnetite is an iron ore and contains oxides of iron. It occurs in igneous and metamorphic rocks. Naturally occurring magnets cannot be given a desired shape as may be required for a particular use. Scientists have developed the process of making magnets from the pieces of iron. These man-made magnets are known as artificial magnets. So student, magnet क्या है? कोई वो ऑब्जेक्ट, वो मटेरियल जो आपके मेटल्स को अट्रैक्ट करता है, जैसे आयरन, निकल और उनके अलॉयज को। लेकिन कुछ हमारे मेटल्स ऐसे भी हैं जिसको वो अट्रैक्ट नहीं करते, लाइक सिल्वर, गोल्ड, एल्यूमिनियम एक्सेट्रा। एंड स्टूडेंट्स, जो हमारे पास नेचुरल मैग्नेट थी उसको हम शेप नहीं चेंज कर सकते थे, इसीलिए साइंटिस्ट ने कुछ प्रोसेस डेवलप किए और मैग्नेट्स बनाई। और वो किससे बनाई? पीसेस ऑफ आयरन से, और उसको हम क्या बोलते हैं? आर्टिफिशियल मैग्नेट. हियर इज magnets of different shapes. Artificial magnets are made in different shapes like a bar magnet, a cylindrical magnet, a dumbbell shaped magnet, a horseshoe shaped magnet, a ring shaped and a needle shaped magnet. So these are the different shape of artificial magnets. These differently shaped magnets are used in different objects of daily uses as well as for scientific studies and researches. Artificial magnets are made of iron, soft iron and alloys of iron, nickel and cobalt. So student, these are the different shape of artificial magnets which is made by humans. Look at these pictures. Magnets of different shapes: dumbbell shaped magnet, horseshoe shaped magnet, ring shaped magnet, bar magnet, needle shaped magnet. Now we have an activity. Activity 1. Aim to sort out magnetic and non-magnetic materials. Materials required: an iron nail, a steel pin, a metal ring, a piece of stone, buttons, an iron key, a metal spoon, a plastic spoon, an eraser, a piece of cardboard, cotton, a copper wire, a glass bottle, etc. and a magnet. So these are the things you need to perform this activity. Here is procedure. Bring the magnet close to every object one by one. Observe if it is attracted by the magnet or not. Note the objects in the table as shown. Look at this picture, students. Name of the object, materials of the object attracted by the magnet. So that's how you have to perform this activity. It's very easy. You have to take a magnet and take it close to the every object which is attracted. You have to write here yes, and which is not, so you have to write here no. You can do this activity in the presence of your teacher. Here we have magnetic and non-magnetic materials. Let us perform activity with some objects made of different materials. Do you know? Alnico and alloy is used to make good quality permanent magnets. So this is a material which we use to make permanent magnets. Here is, from the observation of this activity, we can conclude that materials like iron, nickel, cobalt and their alloys are attracted by the magnet. Such materials are called magnetic materials. On the other hand, materials like wood, plastic, rubber, paper, brass, cotton, glass, copper, aluminium, stainless steel, etc. are not attracted by the magnet. These materials are called non-magnetic materials. Get it, students? So it's very easy and interesting. Here as we have check and mate, you can do it by yourself as we already read about these things. Now we have properties of a magnet. A magnet has some unique properties. Let us learn about them. So students, now we will learn about the properties of a magnet. Here we have a magnet has two poles. A magnet has two poles. The two ends of a magnet are called its poles and are named as North Pole N and South Pole S. Let us perform an activity to find the significance of the poles to a magnet. Look at this picture first, students. This is a bar magnet, north and south poles of a magnet. Now we have an activity 2. Aim to study the poles of a magnet. Materials required: a bar magnet, some iron dust or fillings or pins or iron nail. So students, from this activity we have to find the poles of magnet. Here is procedure. Spread some iron fillings on a sheet of paper. Hold a bar magnet horizontally from its center and move it on the iron dust. Now lift the magnet. Observation carefully. Observe carefully how the iron dust gets attracted by different parts of the magnet. Look at this picture. That's how you have to spread the iron dust on a paper and then you have to move a magnet on it. Here is conclusion. Maximum iron fillings are cleansing to the magnet at its two poles. Why does most of the iron filling stick only to the poles of the magnet? This is because the power of a magnet is concentrated at its poles. This property of the magnet helps in finding the location of the poles of differently shaped magnets. So students, when you perform this activity, you find that the maximum number of iron fillings है वो आपकी जो magnet है उसके two poles पे आपको दिखाई देगी. So that means with the help of this activity, we can find the poles of any magnet. As you move towards the center of the magnet from its poles, the magnetic power goes on decreasing and becomes negligible at the center. To prove this fact, let us perform an activity. So students, the magnetic power of magnet negligible at the center. Let's learn it through an activity. Look here. Activity 3. Aim to show the power of a magnet is negligible at its center. So here we study about the negligibility of magnetic power at the center. Here is materials required: a bar magnet and a safety pin. Procedure: hold the magnet in one hand and the safety pin in the other. Bring the things close to each other. See that one of the poles of the magnet picks up the pin. Remove the safety pin from this pole and try to stick it to point A, slightly away from the pole as shown in figure. Look at these pictures, students. That's how you have to try to stick a pin. Note that the pin back to the nearest pole. Similarly, try to stick the pin at point B of a magnet. Observe the safety pin again going back to the nearest pole. So students, when you try to stick a pin in the center of a magnet, the pin will go to the nearest pole. Now remove the safety pin from the pole. Try to stick it to the center of the bar magnet at point C. What happens? The magnet does not hold the safety pin at its center. Get it, students? Now we have conclusion. This activity shows that the power of a magnet is the maximum at its poles and minimum or negligible at its center. From this activity, it is clear that the magnetic power of a magnet maximum at their poles. Here we have how to distinguish between a magnet and an iron piece if they look alike. So students, how you will find that is a magnet or an iron piece? If we are given two identical metallic objects, a magnet and a non-magnet, then we can find out the magnet by performing this. So that means here is an activity again. Look here, we have activity 4. Aim to shoot out a magnet and a non-magnet that look alike. Here हम क्या करेंगे स्टूडेंट्स, हम एक मैग्नेट और एक नॉन मैग्नेट सब्सटेंस को फाइंड करेंगे कि कौन सा मैग्नेट है कौन सा नॉन मैग्नेट है, बट वो एक जैसे दिखते जरूर है. ओके, लुक हियर, मटेरियल्स रिक्वायर्ड अ बार मैग्नेट एंड आयरन पीस आइडेंटिकल टू द बार मैग्नेट. Procedure: label the two objects as A and B. Hold the object A horizontally and bring one. Look at this picture. That's how you have to perform the activity. Bring to the end of the object B very close to the center of A. If the end of object B sticks to the center of object A, then the object B is magnet, while object A is an iron piece. If there is no attraction, then hold the object B horizontally and bring one end of object A to its center. If the end of object A sticks to the center of object B, then object A is magnet and object B is ordinary iron piece. So student, you can perform this activity in the presence of your teacher. A magnet attracts magnetic substances. A magnet always attracts magnetic substances when brought close to it. This property of magnet is called attractive property of the magnet. So students, when a magnet attracts anything, that is their attractive property. Let us perform an activity. Activity 5. Aim to show a paper clip standing in air. Here, materials required: an empty ice cream cup, a paper dip made of iron, a stand with a clamp and a thread of sufficient length. Procedure: take an empty ice cream cup and clamp it to a stand. Wrap a small magnet in a piece of paper and keep it in the cup. Tie a thread of the base of the stand and then tie a paper clip to its free end. Be wise enough to take a small length of a thread, bring the paper clip near the bottle of the cup and release it. Observation: the paper clip stands in air. Conclusion: the paper clip is made of iron, which is a magnetic substance. Therefore, it is attracted by the magnet kept in the ice cream cup. So get it, student? Look at this picture. That's how you have to make the setup of this experiment. Here, look here. Look at this picture. A paper clip is standing in the air. So also you can do this activity in your lab with the help of your teacher. Now we have check and mate. As we already read about these things, so you can do it by yourself. A freely suspended magnet always rests in the north-south direction. A freely suspended magnet always rests in the north-south direction. This is called the directive property of the magnet. The north pole of a freely suspended magnet points towards the north direction and south pole towards the south direction. Get it? When you leave freely a magnet, it will be north and south direction. Let us verify this fact by performing an activity. Here is activity 6. Aim to prove that a freely suspended magnet always points in the same geographical north-south direction. Materials required: bar magnet, thread and setup to hang the magnet. Here is procedure. Hang a bar magnet freely using a thread away from all. Note the direction when it becomes stable. Gently disturb the magnet again and observe. Look at this picture. Observation: the magnet begins the stable in the same direction again. Conclusion: a freely suspended magnet always points in the same direction, that is geographic north-south direction. Get it, students? Very easy. Now we have, do you know, the area around the magnet in which magnetic materials are attracted is called the magnetic field. It is the space surrounding a magnet in which magnetic force is exerted. Magnetic field can be measured as lines of force that spread out from the poles of a magnet. So students, वो area जिस area में आपका magnetic force work करता है, that means look at here. If you have a magnet आप उसके आसपास कुछ ऑब्जेक्ट्स रखते हैं तो वो अट्रैक्ट करेगी, जैसे जैसे ऑब्जेक्ट को आप दूर रखेंगे दैट मीन डिस्टेंस इंक्रीज करेंगे, वो अट्रैक्ट नहीं करेगी। सो वो एक एरिया, एक पर्टिकुलर एरिया तक उसका मैग्नेटिक फील्ड होता है, दैट मीन्स उसकी अट्रैक्टिंग पावर वर्क करती है। गेट इट स्टूडेंट्स? नाउ वी हैव फाइंडिंग डायरेक्शन विद मैग्नेट्स। Making the use of the directive property of a magnet, scientists have developed an instrument called magnetic compass. Magnetic compass is a simple device which is used by sailors, navigators, pilots, soldiers, mountaineers, etc. to find the direction. It is also used by students in performing scientific experiments. So students, अब आप सबको पता है कि हमारे मैग्नेट में डायरेक्टिव प्रॉपर्टी होती है। इस प्रॉपर्टी का यूज करके साइंटिस्ट ने एक इंस्ट्रूमेंट बनाया दैट इज मैग्नेटिक कंपास, जो हमारे सेलर्स, नेविगेटर्स और बहुत सारे लोग यूज करते हैं किस लिए? टू फाइंड द डायरेक्शन। हियर इज मैग्नेटिक कंपास। A magnetic compass consists of a small and lightweight magnetic needle pivoted at its midpoint so that it can freely rotate in a horizontal plane. The needle is enclosed in a flat circular aluminum box. Aluminum is a non-magnetic substance with a glass plate at the top. At the base of the box, the four main directions, that means north, south, east and west, and four sub-directions northeast, northwest, southeast and southwest are marked. Generally, the north pole of the magnetic needle is painted red and the south pole blue or black. When the magnetic compass is placed on the horizontal surface and needle is allowed to come to rest, the needle aligns itself along north-south direction. The north pole of the needle points towards the north and south. Pole of the needle points towards the south, so the direction can be located easily with the help of magnetic compass. So students, magnetic compass में एक magnetic needle होती है. Look at this picture. This is a picture of magnetic compass. So that's how magnetic compass look, and it is used by scientists and some sailors and navigators to find the direction. And when you put it on a horizontal direction, तो क्या होता है कि जो आपकी needle है आपके कंपास की नॉर्थ साउथ डायरेक्शन में रेस्ट पे होती है. Get it students? Now we have making a magnet. We can convert an ordinary piece of iron into a magnet by magnetizing it with a magnet. Here we have, let us perform an activity. Activity 7. Aim to make magnet or magnetizing a iron bar. Materials required: a bar magnet and an iron bar. Look at this picture. That's how you have to arrange your setup of activity. Now we have procedure. Lay an iron bar on a table. Hold a bar magnet vertically at one end of the iron bar so that one of the poles of the magnet, say north pole, touches the iron bar. Rub the magnet along the length of the iron bar till you reach its other end. Lift the magnet from the other end vertically and bring it back in the direction as shown in the figure, so that same pole touches the iron bar again. Repeat the process for at least 40 to 50 times until the iron bar gets magnetized. Now test it for magnetic property by bringing small iron pins near it. So student, that's how you can change a piece of iron into a magnet. While making a magnet, take special care that the pole of the magnet does not rub the iron rod backwards. We can increase the magnetic power of a magnet by dragging magnet in the same manner over a large number of times. So students, जब भी हम कोई मैग्नेट बनाते हैं तो हमें ध्यान रखना चाहिए वो बैकवर्ड डायरेक्शन में ना हो, क्योंकि जब हम एक ही डायरेक्शन में वर्क करते हो तो वो हाईली मैग्नेटाइज होती है. Get it students? Now we have poles of a magnet attract and repel each other. A magnet shows the phenomena of attraction and repulsion with another magnet. This is because like poles of two magnets repel each other, whereas unlike poles attract each other. So students, that is the thing कि अगर आप दो मैग्नेट लेते हैं और उसके सेम पोल्स, दैट मीन्स नॉर्थ पोल एक दूसरे को रिपेल करेंगे, नॉर्थ साउथ पोल एक दूसरे को अट्रैक्ट करेंगे. सो दैट मीन्स अनलाइक पोल्स अट्रैक्ट and like poles repel. Get it students? Let us verify the property of attraction and repulsion by performing an activity. Activity 8. Aim to study attraction and repulsion between two magnets. Materials required: 2 bar magnets, a wooden stand and a thread. Procedure: suspend one of the bar magnets with the help of the thread. Let it come to rest Now, bring the north pole of the second magnet near to the south pole of the suspended magnet. The south pole of suspended magnet moves toward the north pole of the second magnet. Look at this picture. That's how you have to do this activity. Repeat the experiment by bringing the south pole of the second magnet near the north pole of the suspended magnet. The two get attracted again, so two dissimilar or unlike poles attract each other. Get it, student? That's how you can perform this activity. It's very easy. Now bring the south pole of the second magnet near the south pole of the suspended magnet. What do you observe? The south pole of the suspended magnet moves away from the south pole of the second magnet. Similar behavior is seen when the north pole is brought near the north pole of the suspended magnet. Look at this picture. Thus, similar or like poles repel each other. Here, repulsion is the sure test of magnetism. Magnetic attraction is possible between a magnet and a magnetic substance. However, magnetic repulsion is possible only between the like poles of two magnets. Hence, repulsion is a sure test of magnetism. Here is activity 9. Aim to prove that repulsion is a sure test of a magnetism. Materials required: a bar magnet, an iron object, a wooden stand, and a tray. Look at this picture. That's how you have to set up your activity setup. Procedure: suspend a bar magnet and bring any end of the object to be tested close to the both poles of the suspended magnet one by one and see what happens. If the end of the object is attracted by both the poles, then it's simply a magnetic substance. And if the end of the object is repelled by one of the poles of the suspended magnet, then it is a magnet. So students, that is repulsion. अगर आपको ये टेस्ट करना है कि ये मैग्नेट है कि मैग्नेटिक सब्सटेंस, सो हम रिपल्शन टेस्ट करते हैं. रिपल्शन कैसे टेस्ट करते हैं? आप सबको पता है कि लाइक पोल्स एक दूसरे को रिपेल करते हैं. सो अगर आपकी कोई ऑब्जेक्ट आप अपनी बार मैग्नेट के पास लेकर जाते हैं, अगर दोनों पोल्स उसको अट्रैक्ट करते हैं, सो दैट मीन्स दैट इज अ मैग्नेटिक सब्सटेंस. और अगर एक पोल रिपेल करता है और एक अट्रैक्ट करता है, सो दैट मीन्स देयर इज अनदर मैग्नेट. यूजेस ऑफ मैग्नेट्स. Magnets find a wide use in our homes, offices, industries, toys and games. Some of them are as follows. Look here. In fancy stickers and decoration to be fixed on refrigerators and iron almirah. Second, to separate iron or magnetic substances from non-magnetic substances in the scrap. Third, credit, debit and ATM cards have a magnetic strip which contains the necessary information to connect with the account. Come to the next. Video and audio cassettes contains a reel of the magnetic tape. The audio and visual information is encoded on the magnetic coating of the tape. Get it, students? Look at these pictures. Magnetic stickers, audio video cassettes, credit card and ATM card. Here we have magnets are also used as electromagnet. Speakers and microphones of all sound producing electrical devices have ring-shaped magnets in them. In electric motors used in fans, coolers, mixer, grinder, etc. So these are the things we use in our daily life and they have some use of magnets. Now we have precautions while handling magnets. Certain precautions should be taken while handling magnets, otherwise they may lose their magnetic power. When a magnet loses its power is called demagnetized. Some of the precautions are as follows. So students, अगर आप मैग्नेट्स को अच्छे से नहीं रखते हैं तो वो अपनी मैग्नेटिक पावर का लॉस कर देते हैं and that is demagnetization. Look here, never hit or beat a magnet with anything. Do not throw a magnet or let it fall on the floor. Do not heat a magnet. There are certain objects in our homes whose working gets affected in the presence of magnets. All electrical and electronic devices can start malfunctioning in the presence of magnets. Therefore, magnets should be kept away from things like television, radio, transistors, tape recorder, remote control, computer, etc. So students, अगर आपके पास बहुत हाई मैग्नेटिक पावर वाली कोई मैग्नेट है और उसे आप अपने घर में रख रहे हैं, सपोज आपका टीवी, आपका कंप्यूटर, ये सब चीजें फ्लक्चुएट करना स्टार्ट कर देंगी क्योंकि वो मैग्नेटिक फील्ड उनको अफेक्ट करेगा. Get it, students? Now we have care of magnets. When magnets are not in use, they should be stored properly. Bar magnets should always be stored in pairs between soft iron pieces called keepers. In between the keepers, they should be always placed in pairs and their poles should be opposite to each other. However, a U-shaped magnet needs only one keeper to store it. Look at this picture. Here is keeper, bar magnets, keeper. Here is U-shaped magnet, keeper. Storing magnet by using keepers. When magnets are dropped frequently or they are hammered or brought into contact with other magnets repeatedly, they lose their magnetism. Heating a magnet to a certain temperature can also produce the same effect. So students, what we learn in this chapter about the magnets, now we will discuss it in a nutshell. Here, magnetite to an iron ore which has magnetic properties. Next, a magnet is a substance that has the property of attracting objects made of metals like iron, nickel, cobalt and their alloys. Here we have next, the two ends of a magnet are called its poles and are named as North Pole and South Pole. The pole of a magnet always exists in a pair. A magnet always attracts magnetic substance when brought close to it. This property of magnet is called attractive property of the magnet. A freely suspended magnet always rests in north-south direction. The area around a magnet in which magnetic materials are attracted is called the magnetic field. Magnetic attraction is possible between a magnet and a magnetic substance. So students, here is some keywords. Look here. Magnet, the material which attracts iron. Magnetic poles, the ends of a magnet. Magnetic field, a space surrounding a magnet in which magnetic force is exerted. Demagnetization, a magnet losing its magnetic property. Here is electromagnet, magnet made by passing the electric current. Thank you students. We will meet again in the next chapter with some interesting concepts.